Dozens of kilometers above our heads, the universe stretches out. It is far more vast than we can possibly imagine, yet it is anything but empty. Incredible phenomena occur in space, things the human mind can barely comprehend. Stars inside stars, planets made of diamonds, black holes the size of an atom, and even hypothetical white holes. Space is an astonishing place, and in this video I'll share facts about it that will truly amaze you. Earth is not perfectly round. You've probably seen photos of Earth taken from space, and in them our planet looks perfectly spherical. However, that appearance is deceptive. In reality, Earth is not a perfect sphere. And to immediately disappoint flat Earth believers, due to its rotation, the planet bulges slightly at the equator, giving it a subtly flattened shape as if something enormous sat on it. The difference may seem minor, but Earth's equatorial diameter is about 3% larger than the polar one, which equals roughly 41 kilometers. For comparison, that's twice the distance between the peak of Mount Everest and the deepest point of the Mariana Trench. The sun is not burning. If you've ever stepped outside, you've certainly felt the warmth of the sun's rays. But contrary to popular belief, the sun is not burning in the usual sense. Combustion is a chemical reaction involving the rearrangement of electrons within atoms. In the sun, however, a thermonuclear fusion reaction takes place. Hydrogen atoms fuse into helium, releasing an enormous amount of energy. Electrons play no role here. The very nature of the elements changes. Every minute, the sun converts millions of tons of mass into energy, equivalent to the explosion of hundreds of billions of tons of dynamite every second. Such a reaction requires extreme conditions. Pressure in the sun's core is hundreds of billions of times greater than Earth's atmospheric pressure, and temperatures exceed 16 million degrees, the most massive object in the solar system. Despite constantly losing mass through nuclear fusion, the sun remains the most massive object in the solar system. About 99.85% of the system's total mass is concentrated within it, while all the planets combined account for only a tiny fraction. Although the sun is made primarily of light gases, hydrogen and helium, the immense pressure in its core compresses matter to extraordinary densities. The core occupies only about 2% of the sun's volume, but contains nearly half of its total mass and is roughly 15 times denser than lead. As a result, the sun's diameter is about 109 times greater than Earth's, and its mass is roughly 333 times larger. The heaviest known star. By cosmic standards, our sun is far from a heavyweight champion. One of the most massive known stars is R136A1. Despite its unremarkable name, its mass is about 315 times greater than that of the Sun, equivalent to tens of millions of Earths. This star lies within the Tarantula Nebula, approximately 163,000 light-years away. It belongs to the rare Wolf-Rayet class of stars, rich in heavy elements such as helium, carbon, and nitrogen. Because of this, it is extraordinarily bright. If placed next to the Sun, our star would look as faint as the Moon does next to daylight. The largest known star. Despite its immense mass, R136A1 is not the largest star by size. That title belongs to Scuti. Its dimensions are staggering. Its radius is about 1,700 times larger than the Sun's, and its diameter exceeds 2 billion kilometers. If the Sun were displayed as a single pixel on a computer screen, Scuti would fill nearly the entire display. Fortunately, it is located more than 5,000 light-years away from Earth. Even traveling at rocket speed, it would take about 10 years to fly around this star, while a non-stop journey by train at 80 km/h would last several thousand years. The ninth planet beyond the orbits of the known planets lies the cold, dark Kuiper belt. Some objects there follow unusual, elongated orbits that don't align with standard gravitational models. Scientists have proposed that this strange behavior may be caused by an undiscovered massive planet moving along a distant orbit. It is believed to be about 10 times more massive than Earth, with an orbit so vast that a single revolution around the Sun would take between 10,000 and 20,000 years. Because of this extreme distance, the planet has never been directly observed and remains purely theoretical. How many stars are in the universe? Counting every star in the sky by hand is impossible, but mathematics allows us to estimate the number. Our galaxy, the Milky Way, is thought to contain between 100 and 400 billion stars. Astronomers estimate that the universe may contain around 10 trillion galaxies. Multiplying these figures gives an approximate total of 1 septillion stars, a number with 24 zeros, representing a truly endless cosmic ocean. Now that we have an approximate number, let's imagine how long it would take to count every star if you counted one per second. It would take over 31 quadrillion years. Obviously, such a mission is impossible, but we may have just invented the most useless job that could theoretically be assigned by NASA. Amazing supernovae. Unfortunately, stars are not eternal. When they die, their deaths are often marked by colossal explosions known as supernovae. Stars that are at least 8 times more massive than the Sun burn enormous amounts of hydrogen in their cores during their lifetimes. The energy produced creates outward pressure that prevents the star from collapsing under its own gravity. But once the fuel runs out, gravity wins, and the star collapses violently. In just seconds, an object millions of times heavier than Earth explodes with unimaginable force. NASA animations vividly show how shockwaves tear the star's outer layers apart. Many people imagine supernova explosions as perfectly spherical, but this is not always the case. A striking example is supernova 1987A, located about 160,000 light-years from Earth. When it exploded in 1987, scientists were surprised to discover that the blast was asymmetrical energy, was released more powerfully and more rapidly in certain directions. As a result, the explosion appeared like a bow tie from one angle and like a sinister eye from another. What do you see? Black holes. Some supernovae leave behind truly terrifying remnants. When the core of a massive star loses the thermal pressure that counteracts gravity, it begins to collapse inward under its own weight. This process gives rise to one of the most mysterious phenomena in the universe, a black hole. This is not like a building collapsing. The star literally implodes into itself, shrinking until it reaches the event horizon, the boundary beyond which not even light can escape. To overcome a black hole's gravity, an object would need to travel faster than 300,000 kilometers per second, meaning anything slower than the speed of light is trapped forever. Near a black hole, space and time themselves become distorted. To an outside observer, processes appear to slow down and freeze, while the object turns into an infinitely dense body, seemingly suspended in time. In movies, black holes are often depicted as planet-sized voids, but in reality they can be vastly larger. In the galaxy cluster Abell 885, more than 20 billion light-years away, lies the black hole known as TON 618. Its mass is estimated to be about 66 billion times greater than that of the Sun, and its diameter exceeds 390 billion kilometers, roughly 2,600 times the distance between Earth and the Sun. It is no surprise that TON 618 is classified as an ultramassive black hole. However, there is another extreme end of the spectrum. Unlike stars, black holes can also be incredibly small. Some scientists theorize the existence of microscopic black holes no larger than an atom. Yet even such a tiny black hole would have a mass comparable to that of a mountain. And if you wouldn't want to collide with Mount Everest, it's best to stay away from miniature black holes as well. White holes, black holes receive most of the attention, while their hypothetical opposites, white holes, are rarely discussed. According to theory, a white hole is an object into which nothing can enter. If a black hole consumes matter, a white hole does the opposite, expelling matter outward. Such an object would be extraordinarily bright, blasting immense amounts of energy into space. The concept of white holes emerged in the 1970s from mathematical calculations. They are thought to form in a way opposite to black holes, not by collapsing inward, but by erupting outward. For now, white holes remain purely theoretical. However, supernovae were once only theories as well. Perhaps in a few decades, we will discover a white hole and finally shed light on this cosmic mystery. Diamond rain. On Earth, rain is an everyday occurrence, but in some parts of the solar system it would be priceless. On gas giants such as Jupiter, Saturn, Uranus, and Neptune, it may literally rain diamonds. The process begins in their methane-rich atmospheres. During powerful storms, electrical discharges break apart methane molecules, turning carbon into soot. These particles clump together, compress, and form chunks of graphite. Pulled downward by gravity, they fall into regions of immense pressure, where carbon atoms are compressed into diamonds of astonishing size. Some of the diamonds formed in the atmospheres of gas giants can reach sizes of about 1 centimeter. On planets like Saturn, such storms occur so frequently that roughly 1,000 tons of sparkling crystals may fall each year, enough to create a dazzling outfit for Jennifer Lopez at the Met Gala. The Diamond Planet. When it comes to planets literally made of diamonds, gas giants pale in comparison to the exoplanet 55 Cancri E. This so-called super-Earth was discovered in the constellation Cancer in 2004. Scientists have determined that the planet is extremely rich in carbon. It is about 10 times more massive than Earth, yet its radius is only about twice as large, indicating an exceptionally high density. Much of the planet is believed to consist of carbon compounds, such as graphite and diamonds. Researchers even suggest that its inner layers may be covered by a thick shell of pure diamond, accounting for roughly 1/3 of the planet's total mass. If this planet were valued based on the market price of its diamonds, it would be worth approximately 27, followed by 29 zeros, a number beyond comprehension. Unfortunately, tourism is not an option. Surface temperatures exceed 2,100 degrees, making 55 Cancri EE a truly extraterrestrial diamond that no spacecraft could ever land on. Saturn's hexagonal storm. At school, we're usually told that Saturn's most remarkable feature is its rings. But this planet has something far more unusual. At its north pole, a gigantic storm in the shape of a perfect hexagon has been raging for decades. It was first spotted in the 1980s in images from the Voyager spacecraft, and the Cassini mission in 2004 allowed scientists to study the storm in much greater detail. Thermal imaging shows that the structure is about 32,000 kilometers wide, nearly 100 kilometers deep, and features wind speeds exceeding 350 km/h. But how does nature manage to create such precise geometric shapes when the universe rarely follows straight lines? Scientists attempted to recreate this phenomenon using computer simulations and found that small disturbances in the powerful jet streams circling the pole cause airflows to collide and twist, forming a stable hexagonal pattern. The universe didn't cut corners. Everything emerged naturally through the laws of physics. The greatest light show. You've likely seen the Northern Lights, one of the most beautiful natural phenomena on Earth. Brilliant waves of green, red, and purple ribbons appear to dance across the night sky. This glow is caused by the solar wind. Charged particles collide with Earth's magnetic field and are guided toward the poles, where they interact with atoms in the atmosphere, releasing energy in the form of light. Oxygen produces green and red hues, while hydrogen and helium glow blue and purple. But auroras don't exist only on Earth. The solar wind reaches other planets as well. In 2016, the Hubble Space Telescope captured extremely powerful auroras on Jupiter. Its magnetic field is about 20,000 times stronger than Earth's, and its auroras cover regions larger than our entire planet. Saturn is no exception. Ultraviolet images taken in 2018 revealed spectacular polar lights. Although they appear blue in images, data from the Cassini spacecraft suggest that to the human eye, they would look red and violet. We've now seen auroras on Earth, Jupiter, and Saturn. Which one do you think looks the most beautiful? Let us know in the comments, we'll see who comes out on top. Russian doll stars. It may seem like there's plenty of space in the universe for every star, but according to the Thorne-Zhitkov theory, some stars may actually exist inside other, larger stars like cosmic Russian nesting dolls. It sounds unbelievable, yet there are two main hypotheses that explain how this could happen. In the first scenario, a binary star system is involved. The more massive star explodes as a supernova and becomes a neutron star. Over time, it ends up embedded within the outer layers of its companion, like a cosmic parasite living inside a hot gaseous shell. In the second scenario, the neutron star formed in a supernova is violently propelled straight into a red supergiant. It's like kicking a soccer ball into a goal, except the ball weighs as much as 2 suns, and the goal is heated to thousands of degrees. Unusual sunsets. In 2015, a Mars rover captured an extraordinary sight, a blue sunset on Mars. During the day, the Martian sky appears orange, which is the complete opposite of what we see on Earth. On our planet, the blue color of the sky is caused by sunlight scattering off molecules in the atmosphere, which scatter shorter blue wavelengths more effectively. At sunset, sunlight travels through a thicker layer of atmosphere, scattering the blue light away and leaving behind red and orange tones. Mars, however, tells a different story. Its thin atmosphere is filled with dust, rich in iron oxides, the same rust that gives the planet its red color. During the day, red light scatters more strongly, making the sky look orange. But at sunset, the dust absorbs much of the red light, allowing shorter blue wavelengths to dominate and creating an indigo halo around the setting sun. The darkest sunset, however, would be found on Venus. The planet's atmosphere is so dense and saturated with carbon dioxide and sulfuric acid that the sun is barely visible. Images taken by the Soviet Venera probes in 1981 revealed a sky with a toxic yellow hue. A Venusian sunset would look like a brightly painted room where the lights suddenly go out. And what about planets without an atmosphere, like Mercury? There, the sky would be completely black both day and night, just like on the Moon. Without molecules to scatter sunlight, there's simply nothing to make the sky glow. Looks like we've found the perfect home planet for all goths. Which of these facts surprised you the most? Tell us in the comments below the video. Thanks for watching.